So we also use exponential models to do Newton's law of heating problems. And the Newton's law of heating simply says that if you take an object and you put it in an environment that is warmer than itself, it can never heat to hotter than the environment it's in. So if we put something in an oven at 350, it can never get past 350, right? If you leave something outside on a hot summer day, whatever the temperature outside is, that is as hot as the object will get without some kind of external heat source. So there's a slight variation on this. The positive temperature difference is still PTD, and that is, we're going to be built the similar way. But now to get the current temperature of the object, we have to subtract the temperature from the outside temp. So now what the model is giving you from the calculator is it's giving you the temperature of the environment minus its current temperature. So we're going to have to make an adjustment on our y values again. So we want the positive temperature difference, and that's why the subtraction feels like it's reversed, because if it's something hotter, I now have to subtract the current temperature of the object from the environment, so I get a positive number. When we were cooling things, we took the object was what was warmer, so we subtracted the temperature of the environment from that. So now what we're going to do is we're going to cook our favorite holiday turkey. We're going to bake it in an oven at 425 degrees until it reaches an internal temperature of 165. To help you, your mom gave you the following data set from her turkey last year. X is the time in hours after the turkey was placed in the oven, and Y is the temperature of the turkey taken with an internal thermometer. So we first need to build the model so we can answer any questions about it. So once again, T, little t, is the time, and that's going to go into L1 as is. But now, to get L2, we're going to take the 425 degree oven and subtract the actual values from it. So in our calculator, I'm going to go to Stat, List, Edit. I'm going to clear my list, and we're going to enter our new y values. So we measured it every hour for 4 hours. And then we're going to go to L2. And this time I have to say 425 minus 40, because the turkey was really cold, right? 425 minus 105. 425 minus 128. 425 minus 155. 425 minus 170. And just in case we need the average error or any errors, I'm going to go ahead and calculate those now so the lists are preserved. So I'm going to go ahead and clear L3, clear L4, and clear L5. So let's build our model. So we have to go to Stat, Calculate, Exponential Regression. We want L1, comma, L2, comma, and then we're going to send it to Y1. So here's our model. And let's write this down. So the positive temperature difference as a function of T is 368.621 times 0.905 raised to the T. So that's the model that it produced. Now I want to predict, if you put the turkey in at 1 p.m., what time will it reach 165 degrees? Round your answer to the nearest minute. So in order to predict the turkey, the actual value of 165, I need to make an adjustment. So if we look at this formula, we see that the actual time is the environment, which is 425, minus the model we built. So if I go into y equals, I'm going to say second insert because I want to put the number before. And you can now see the cursor isn't black anymore when it blinks. It's just blinking the number. And I can type 425 minus and see if it inserted everything before and hit enter. So now it's going to do that auto adjustment for me. And I want to set the temperature equal to 165. I'm going to go to my window and I'm going to set this, remember we're measuring in hours now, so I'm going to go out 6 hours and then I'm going to zoom fit. So you can see the turkey's warming up. And once again, it warms very quickly and you see it starting to slow down a little bit. And then there's 165 degrees. So if we do second calc, I'm hitting y equals instead of second calc. There we go. Intersect. There's the first graph, the second graph, and guess. And the time is 3.51 hours. So that's how long it takes to get to 165. But now we want to know, well, what time is it? So 3.51 hours is 3 hours plus 0.51 of an hour. So I need to convert that to minutes. So 0.51 hours, there are 60 minutes in 1 hour. And this multiplies out to be 30.72 minutes. So this is approximately 31 minutes because we want to round to the nearest minute. So 1 p.m. plus 3 hours is 4 p.m. And then if we add 31 minutes, we get that it's 4:31 p.m. when the turkey is cooked. So suppose you fall asleep and forget to take it out on time. What will the temperature be at 6 p.m.? Round to the nearest degree. So now, if we go back to our calculator and go to second calc value, and I type in x equals 6, we get that the temperature is 221.9 degrees. Oh, sorry, I made a mistake. I typed in 6. We put the turkey in at 1 o'clock. So 6 p.m. is 5 hours later. So we need to put in 5. So if we put 5 in, we get that it's 201 degrees if you round to the nearest degree. So the temperature is 201 degrees Fahrenheit. When will the turkey reach 350? So if we just leave this turkey in there, forget about it, and let it heat up until it gets to 350 degrees. So I'm going to go to y equals, and I'm going to change this to 350 degrees. And we know we're going to have to adjust our window because it was only at like 200 degrees at 5 hours. So let's just go a full day. Let's just go way out. And now I'm going to zoom fit. So there's the turkey heating up. And now you can really see it starts to slow down. So once it hits a certain point, it starts slowing down. There's 350. So now if we go to second calc intersect, first curve, second curve, enter, it's about 16 hours. So once again, they want us to round to the nearest minute. So the time is 16.02 hours. So 0.02 hours is 1.2 minutes. So 1 p.m. plus 16 hours is 5 a.m. So 12 hours takes you back to 1 a.m., right? And then you add the remaining 4 hours and you get 5 a.m. And so if we add the 1.2 minutes, it's basically 5:02 because we want to round to the nearest minute. So it's 5:01 and you're actually almost at 5:02 a.m. So it would take 16 hours for this turkey to get to 350 degrees.